30 years ago, we had zero scientific proof that a single planet existed outside our solar system. Today, we've cataloged over 5,300 of these alien worlds. Early discoveries were mostly limited to massive, swirling gas giants like Jupiter, worlds completely hostile to life as we know it. But as our tools improved, our focus shifted to Gliese 667, a triple star system about 23 light-years away. Specifically, astronomers zoomed in on its purge star, Gliese 667c, an orange-red dwarf that radiates barely 1% of our sun's light. What they found orbiting this dim little star caught everyone off guard. Instead of one lonely planet, the data indicated up to 4 rocky worlds crammed into the star's habitable zone. The standout is Gliese 667cc. With an Earth Similarity Index of 0.85, it is closer to a twin for our homeworld than nearly anything else we've ever seen. However, the scientific definition of habitable can be incredibly misleading. Meeting the bare minimum criteria for an Earth-like classification does not make a planet a paradise. In astronomy, habitability is ruled by a single question: can liquid water exist on the surface? That requirement dictates a very specific temperature range. This map shows the habitable zone squeezed around Gliese 667c, fitting entirely inside Mercury's equivalent orbit. This proximity triggers tidal locking, freezing the planet's rotation, forcing one hemisphere to face the sun forever while the other points to space. This leaves you with 2 extreme choices: an eternal blazing day side or a freezing perpetual night side. Survival would require a thick Earth-like atmosphere to distribute that heat. If everything works perfectly, the night side might stay a relatively stable 86 degrees Fahrenheit. But managing temperature distribution is moot if the planet's other physical properties crush you upon arrival. Gliese 667cc is a super-Earth, and its massive size means it has a gravitational pull roughly 60% stronger than what we experience at home. To a human visitor, that physics translates to a visceral burden. A 165-pound person would suddenly weigh a crushing 265 pounds. This high mass also allows the planet to hold a massive, Venus-like atmosphere. The resulting surface pressure could be equivalent to being kilometers deep in Earth's oceans. Even if you could survive the pressure, you still have to deal with the host star's violent instability. Red dwarfs are known to emit radiation flares 1,000 times stronger than our sun. Because planet CC orbits so closely, it is regularly blasted by these energetic particles. For a human visitor, the planet's actual physical conditions would lead to being crushed, fried, or boiled instantly. If this system is a literal death trap, why is it the focal point of so much research? We have to look at the neighboring planets, C and CF. These are identically miserable, freezing super-Earths within the same system. Finding a densely packed cluster of multiple rocky worlds around a single star changes our statistical model of the universe. It proves these candidates aren't rare flukes, they're a standard outcome. And red dwarfs account for over 70% of stars in our galactic neighborhood. This creates massive scientific efficiency. Instead of checking 10 different stars to find one candidate, astronomers can focus on one red dwarf and find a wholesale batch of worlds to study. These worlds are a nightmare for human habitation, but their sheer volume changes the math. We've discovered a factory for extreme environments, and that is where we will likely find life, no matter how strange it turns out to be.